Here are 3 common mistakes that I see my students make when we're trying to identify the y-intercept of a rational function. Now, to identify the y-intercept for any function, all you simply need to do is set x equal to 0 and then go ahead and solve for y. But for rational functions, it's actually a little bit easier than that, because when I go ahead and replace my 0 in for y, I have 0 equal to a fraction. And if I have denominator or an x in my denominator, I need to multiply that on both sides. Therefore, all I simply really need to do is just set my numerator equal to 0. Because when I multiply an x minus 2 on both sides, x minus 2 times 0 is just going to be 0. And the x minus 2's are going to divide out, leave me just my numerator. Now again, students will get to this, but they'll still make the mistake. They'll still say, I don't know, the y-intercept is equal to 4. But unfortunately, ladies and gentlemen, this is an incorrect statement. 0 is never going to equal 4. So this is an example of no y-intercept. Now, in the next example, again, students are like, all right, well, let's just go ahead and set this equal to 0, and I get an x squared plus 4. Sometimes they want it to be the difference of 2 squares, so they will maybe just make it in their mind, and they'll say the y-intercept is going to be plus or minus 2. But unfortunately, when we actually go about solving this, subtracting a 4 on both sides, and then taking the square root, we get x equals a plus or minus the square root of a negative 4. Now, I'm not going to continue that down the imaginary number system, because I want you to understand that is now a complex number, right? It cannot be a real y-intercept. So again, when you have imaginary solutions in your numerator, when it's set equal to 0, you're going to have no y-intercept. Now, the last one is something that I harp on with my students every single year. Whenever we're dealing with rational functions, it is so important to make sure you always look to factor first. So before we even go into setting things into numerator and denominator, thankfully, nothing to factor here, nothing to factor here. But here, I see this x squared minus 4. I can factor that down to an x minus 2 times an x plus 2. And then it's going to be divided by an x minus 2. Now, since these two terms are separated by multiplication, I can apply the division property. So actually, what I have is an equation of y is equal to an x plus 2. Now again, a lot of students will recognize here that if you just simply set your numerator equal to 0, you'd have 2 y-intercepts. X equals 2 when you set that equal to 0, and x equals negative 2 when you set that equal to 0. However, it's important to understand, y-intercept as well as x-intercepts cannot occur at discontinuities. X equals 2, that is going to be a whole because it got divided out. We call it a removable discontinuity. So therefore, the only y-intercept is going to be when x plus 2 is equal to 0. So now that is going to give me x equals a negative 2.